Longtime viewers of this channel know that I have a passion for electronics and software development. Though I've been focusing more on CNC and CAD on this channel over the last few years, I will be adding more electronics and software development content over the coming months. Along those lines, I have been using EagleCAD, a printed circuit board design software, for a very long time, since at least 2009, probably even before that. Autodesk purchased Eagle a while back and has fully integrated into Fusion. In the process, they have been adding desperately needed features and capabilities. But unfortunately, in my opinion, they have also further complicated and muddied certain aspects of an already poorly designed application. Today I'm going to walk through the process of creating a 3D package within Fusion Electronics and then associating that package with an existing component. I am going to assume you are already familiar with Fusion Electronic Component Management and the differences between components, symbols, and footprints within a library. The new add from Autodesk is packages, which are 3D representations of a footprint and a component. That will be the focus of this video. If you need more specifics on components, symbols, or libraries, I will link to other videos that I have done, as well as other channels that have done videos on the topic. Let's go ahead and get started. Here we are in Fusion. On the left-hand side, you will see the 4 high-level folders that I have created. I have found it best to separate packages from the libraries, and I also have a third-party library folder, as well as some design elements that I use across multiple designs. All of these items are stored in what is called Fusion Team, which is a cloud-based storage within Fusion. The differences between Fusion Team and other storage locations will come up later, and it is important to understand that there are more than one locations that you can have a library stored within the Fusion ecosphere. In the past, Fusion libraries were stored on the local file system, and for a period of time, Fusion did support that local library storage capability. However, they have slowly converted to a cloud-only storage capability within Fusion Team. I will double-click my library folders here, and I will open up my primary component library, which happens to be CRG Makes. Scrolling down here and clicking on one of the components that I want to focus on today, you will see that there is a little overview of that component right here in the lower left-hand side of the screen. If I double click this component, you can see that it brings up the symbol right here in the center of the screen. And then more importantly though, we have all the different footprints for that component on the right-hand side of the screen. In addition to seeing your component here on the screen in this sort of summary view, you can also see additional details of your component here in the Content Managers tab. So if we click this little arrow here, it will expand your component. And what you see here at the top level is your component. Then you have your symbol. And then you have, in this case, 4 footprints that are associated with the component. We can continue to expand these footprints here, and it'll show the packages that are associated with the footprints. So you will see here that it kind of looks like there are already 4 different packages associated with the 4 different footprints, which is what you're looking for. However, this is where a little bit of my confusion happened, and I'm sure other people are confused. So if we were to hover over this little icon here that looks kind of like a book stacked next to each other, it says that this package only exists on library.io, and to edit it, you must link that package on library.io with Fusion Team. So this is the source of some of my confusion, and it is a source of a continuous sort of rub between me and the library manager in Fusion. So what this really means is that there is no actual package associated with this footprint. Instead, there is a placeholder. And in fact, you can see this over here on the right-hand screen where you can see the different footprints that we have defined, and they are fully connected. But it says here under 3D model that there are just placeholders for the actual package, not an actual 3D model. Now you can see here this QFN28 does have an actual model associated with it because I've done that in the past. So what I would like to do right now is show you how to fix this situation to replace the placeholders with actual models. Now there are two primary ways to do this. You can create your model from scratch, or you can actually import a pre-created model that are available on many of the websites. So I'm going to go ahead and I'm going to start by showing you how to create a model from scratch, and then we will go back and we will use a pre-established model and import that into Fusion 360. All right, so let's go ahead and start. I want to start with the SSOP28, which stands for the Small Outline Package 28. And I am going to double click this pre-existing library IO model and show you what we get. So we double click this, it's going to tell you that the package isn't currently in Team, and so you want to download it from library IO. So I'm going to go ahead and I am going to click import. Now this was very confusing for me for the longest time. I'm going to click cancel on this screen. When it imports it, what you see is nothing. There are no 3D geometries in this screen. And this was very confusing to me because it implied previously that this model is already in library IO, when in fact what is in library IO is a 3D model that only has the 2D representation of the footprint. So what we need to do is we need to go ahead and create this 3D model from scratch using the basis of the footprint. Now Fusion does provide this very cool tool right here. It's called the package generator, and it allows you to very quickly generate packages for standard footprints across a wide range of items. So I'm going to go ahead and I am going to click on this right here. And you can see if you scroll through the package generator, you have things like axial parts, ball grid arrays, chips, we have LEDs, crystals, and we have some other sort of new packaging structures, as well as the traditional dual inline package chips. Now before you dig right into this, you do need to have your data sheet available for the part that you are creating, so you know what your pin spacing is and you know what your offsets and whatnot are. So if I were to pivot over here to Safari, to my browser, I have already pulled up my data sheet for my MCP 23017. You can see that it shows that it is a plastic small outline. It is the otherwise known as an SOIC. So this is important as we get back to Fusion to show you where this is. And you can see there are a number of different drawings here. There's some letters and some designators that show you the different dimensions. Pivoting back into Fusion right here, what you see if we scroll down a little bit more here, you can see that Fusion has a generator that's already built into it for SOIC and SOP packages. This is exactly what we want. So I want to go ahead and I want to click on this guy right here. And you can see it pulls up this little screen and it shows you a bunch of designator letters. We pivot back to the data sheet here, you can see there are also designated letters on the data sheet. Now you do need to make sure that the letters on the data sheet match the letters in Fusion. In many cases they do, so it makes converting this picture here that you see in the screen into a 3D model very, very easy. So let's go ahead and scroll a little bit down in the data sheet here until we get to a table that actually shows us the values which you see right here. This is exactly what we're looking for. Go back into Fusion and we can see here that the first thing we want to ask for is how many pins. We know that it's 28. Now I want to tell you, in this screen, do not hit enter, do not click OK. It'll disappear and it'll create the model for you. You want to hit tab to tab your way through the different fields on this screen. So I'm going to hit tab. Okay, so the next thing is E, which is the pin spacing. All right, so the pin spacing for the SSOP is 0.65 right here. So we'll go back into Fusion and we will type in 0.65. All right, so the next thing we need to know is we need to know what E, L, and B are. So we will look for E, which is 7.4 to 8.2. So we will say 7.4 to 8.2. Then we look for L, 0.55 to 0.95. So we say L, 0.55 to 0.95. All right, now that we have 9.9 entered into D instead of 99, we're going to go ahead and we're going to click add. And you're going to see that it automatically creates this package See how easy that was? Super simple. The only thing that we need to do is we need to close this, and you will notice that for whatever reason, Fusion has put the package vertically when it needs to be horizontal. This is very easy to change. All we need to do is we need to select the model and then click move. It's going to give you a little move icon here, and we're going to go ahead and we're going to rotate it just like that. Whoops, we need to rotate it the other way, and I will tell you why in just a minute. So I'll click top. So we want to make sure that this little circle on top of the package matches the circle that is on top of our footprint so that it is oriented properly. This is not a huge deal for the 3D model, but it's nice to make sure that they line up. But what you can see here is it is in 3D space. It lines up perfectly with the footprint and the outlines that are provided. So we will go ahead and we will click OK. And there you have it. All you need to do now is save this package into your packages folder. So if I click save here, you will see here that it automatically, for me, defaults to the packages area. So I will go ahead and I will click save, and it'll automatically associate this package with your footprint in the Fusion library. So if I click save, we're good to go. All right, I will click X here and we'll go back to the library, and you can see here if we go back to the component, I scroll down, you can see now that the SSOP 28 now has an actual package associated with it, and you don't have this little book icon. So that is awesome. It has a little arrow here that tells you that you need to push that change up to library IO so it saves in your library IO. Okay, so now let's pivot over if we want to create something by importing a model entirely. How do we do that? Well, that's very easy in Fusion as well. So what we need to do is we need to, I'm going to pick the DIL 28-3 footprint here, and I am going to double click the package here to create a new blank package in Fusion. I'm going to hit cancel. And it is important that you hit cancel at this moment, and I will talk about why at the end here. So okay, what we have is we have the blank footprint here. You can see it's a big, long, dual outline, sort of traditional integrated circuits you got from all the way back in the day from the 70s when the integrated circuits became very popular. So the first thing you want to do is you need to then go find a source for this footprint. So how do we do that? Well, let's pivot back over to the browser here. I'm going to go to, in this case, I'm going to go to Mouser. It's one of my favorite electronic suppliers. And you can see where I had the data sheet here I got from Mouser as well. They also have, for most of their components, they have printed circuit board symbols, footprints, and 3D models. This is super cool. You don't have to do anything. You just open this and then download what they provide. So in this case, they provide the symbol, the footprint, and the model. Now we already have the symbol and the footprint because I had created those previously, but what we don't have is the model. So you can see here, this is the model that it's created. Now we don't need the device on the actual footprint here, so what we want to say is we give us the device only, because we're going to go ahead and we're going to add it to the footprint anyway. And then click download CAD models. And it's going to automatically download it to your downloads folders, whatever you have set. So once you get it downloaded, you can expand that zip file, which I have done here. And what you see in this folder is there's a lot of different things here. So we have the 3D model here, which is represented by a step file. And then you have a bunch of different formats for a bunch of different CAD programs. For Fusion, what you want is the Eagle capability here, and this opens the library. That will provide you the symbol and the footprint if you need it. Now, we don't need the symbol and the footprint, so we won't be loading that here right now, but I do want to show you how to upload the model. So what we want to do is we want to go back into Fusion. I want to click Upload. I will put the step file here, right here. I will drag it and put it into Fusion, drop it right there. And I will click upload. And after a few minutes, you will see that Fusion will upload it, it'll process it, and it will make that 3D model available to the Fusion infrastructure that we have open right now. All right, so Fusion has uploaded, and you can see it now shows up into our libraries folder. It is probably best to put this into your packages folder, but I will show you in a minute why that doesn't matter and why we didn't want to click save right off the bat. So what I want to do is first click on the model, right click, and say insert into current design. And it's going to put that model right there in that design. Once again, you can see that it does not have the proper orientation, but that is super easy to fix. We're going to go to the top view, we're going to rotate it, and you can see here that it looks like everything lines up left and right. We will turn here, and it looks like it's perfectly aligned vertically, so we're good to go. We're going to click OK. Now, this is super, super important. Fusion has linked this model to that specific model, not necessarily the model that we are in. And you can tell that by this little link icon right here. So what we want to do is we want to right click and we want to say break link. If you do not break the link at this point before you save it, Fusion will forever link the model that you have just uploaded to the model that you have just created inside of the package area. That's not a big deal, except that you now essentially have two models that are identical, that are linked to each other, that cannot be broken. If you break the link now before you save it, you will be able to delete this model, and then you will only have one model representing this specific package. And that's what we're going to do. So we're going to go ahead and we're going to click save. It's going to say, hey, do you want to save the deal 28.3? Check, yes we do. Click OK. We can close this. And then what we can also do is we can right click on that model that we uploaded and we can delete it. Again, if you saved it before you broke the link and you go to delete it, Fusion will tell you that there are designs that are associated with that model, so you can't break the link. That is super frustrating to me. I think it is very bizarre and weird. But if you don't save it first and you break the link, then you are good to go and everything is fine. All right, so let's go back into the component here, and I'm going to scroll down. You can see now that the deal 28.3 does have a model associated with it. So if we double click this again, you can see that the deal 28 has a model. You can see it right here, as does the SSOP 28. Super cool. So now if you use these in a design, those two 3D models in addition to the QFN 28 will be available for you to use. I think this is super awesome because you get that 3D model, you can import it into an actual 3D design, and then you can see what it looks like in a 3D space. To drive the point home of how important it is to have an accurate 3D model when you are designing a product, I'm going to show you something that I've been working on for a while, and I hope to do future videos on it. But what you see here is an enclosure that it contains a bunch of individual modules. And what I have done here, I'm going to go ahead and I'm going to expand the actual enclosure that we're using. I'm going to turn the top off. And so what you can see here is a bunch of printed circuit boards that I've created in Fusion with all of their components on and then pulled into this secondary enclosure model to show me where I want to put the printed circuit boards in 3D space. So I'm going to go ahead, I'm going to turn off this sketch right here, and I'm going to actually turn off the entire enclosure and show you how cool this is. Look at this. So I have 4 separate printed circuit boards, all with a variety of components. You can see a bunch of resistors, some integrated circuits, some connectors, all things that I have modeled over the last few months, last few years actually, and they have all come together in this single design. And you can see that we have components on the bottom side. We can see the printed circuit board traces and the polygon fills. You can see some markings that we happen to have on this specific model. Now that model there I did download from the internet, so it had all this additional information. But most of these I've actually created from scratch on my own, either using that generator inside of Fusion or just generating it from the datasheet myself. So this is the power here, so I will turn this back on, I will turn the top back on, and the whole point of this 3D modeling is where do I put the holes so that the LED and the switch will show through. And so if I turn this off and I turn this one on, this is a second model that I created. If I wanted to 3D print it myself, I could do that, and that is right here. All right, that is the video. I hope that I have resolved some of the confusion around Fusion and how Fusion Electronics manages packages and models in association with their components. And if you enjoyed this video, I really appreciate a thumbs up. If you didn't enjoy it, well, then I would appreciate a thumbs up anyway. But leave your comments down below and tell us why. If you are interested in how I do additional electronic work and how I created some of the packages and footprints, then I encourage you to watch this video right here. Once again, thank you so much for watching. Thank you so much for getting this far. And don't forget to be inspired.